the last electronic case in our discussion of the VSEPR model and prediction of molecular shapes based on Lewis structures is a 6-electron pair case. So a 6-electron pair case, and we begin when all of these electron pairs are bonding and none of them is non-bonding. So 6 bonding, 0 non-bonding, and we take SF6 as a typical example in this category. So sulfur hexafluoride, we need to be able to draw a reasonable Lewis structure, and for that first we need to add the valence electrons in SF6. Well, sulfur is located in group 6A, just under oxygen, so there are 6 valence electrons from sulfur, 6 fluorine atoms, and each of them contributes 7 because fluorine is in the halogens group. Okay, it's located in group 7A, therefore it has 7 valence electrons. So the total number of valence electrons in this case would be 48. So 48 valence electrons. If you divide that 48 number by 2, you would get 24 electron pairs. So 24 electron pairs in this sulfur hexafluoride example. Now what we need to do next is we need to draw a Lewis structure, and for that we need to draw the central sulfur atom. So that's the central sulfur atom, which should be surrounded by 6 fluorine atoms. So there are 6 of them. We draw them like that, and then we draw a single bond between the central sulfur atom and each of these surrounding fluorine atoms. The following step would be to satisfy the octet on surrounding atoms, surrounding fluorine atoms. Each of these fluorines so far is surrounded by 2, but we need to make sure that they are surrounded by 8. So we do that on all of them in order for them to satisfy the octet rule, which means they should be surrounded by 8 electrons, and that's the case now. Okay, so each of these fluorine atoms is now surrounded by 8, and there are 6 of them. So if you multiply that 8 by 6, you get 48 valence electrons used up so far in this Lewis structure, and that's in accordance with the number that we had before. Now if you want to check the number of electron pairs, well, there are 4 on each of these fluorines. If you multiply that by 6, you get 24. So again, that's in line with the information that we had before, and therefore this is a possible and acceptable Lewis structure for sulfur hexafluoride. What we need to discuss next is the arrangement of electron pairs, or the orbital shape, the overall arrangement of electron pairs around the central atom, and that's a possible model using Darling models. The shape is actually octahedral, the shape of octahedron, if you like. So that's the orbital shape or arrangement of electron pairs is octahedral. Now to go on to the molecular shape, it should be the same actually. That's because there are no lone pairs on the central sulfur atoms. So the molecular shape should also be octahedral. So in this case of sulfur hexafluoride, to conclude, 6 of the electron pairs are bonding, none of them is non-bonding. The arrangement of electron pairs or the orbital shape is octahedral, and also the molecular shape is octahedral, and that's because there are no lone pairs on the central sulfur atom.